Um, Welcome everybody. It's Society of Amateur Radio Astronomy, uh, uh, Australia, Drake's Lounge, Australia. The what we have going on is in April 8th to 9th, we do have the Western Conference on the in Dallas at the University of Texas in Dallas, and we'll be having the solar eclipse then. Also, I'm looking for articles for the journal. I need them by April 12th, and hopefully some of the solar eclipse pictures can come into that. That'd be great. And I think that's about it. So I'm going to turn it over to Paul. Go ahead.
All right, thanks, Rich, and hi to everybody. The main thing from me was just following up from our physics education conference, which took place a couple of weeks ago now, and I presented a paper there. Last year I did astronomy during the school day, looking at a whole range of options that students can get involved with. This year I did specifically radio astronomy to see what options there might be there. I ran through many of the things that we do in the 50 minutes that I had available. And then I listed resources, including SARA and some of the others, so the Astronomical Society and so on. The problem with the Astronomical Society at the moment is that our data is not being streamed correctly. But because they've moved to a new website, and that means that the data is not coming out as it should. And that's part of what the group is working on at the moment, to try and get that data out to anybody else who wants to use it. So the feedback from the conference paper, they give us a feedback from participants, was asking whether there are some actual teaching materials, actual lesson plans, or much more specific lesson plans, lesson materials, resources that could be given to students so that they can access some of the radio astronomy activities. And my answer at this stage is I don't know, but I wondered whether there would be materials within the SARA website or tucked away somewhere else that are specifically school-based activities. That's a question I'm raising. I don't know the answer to it at this stage, but I think it's perhaps something we could address so that when schools are interested in radio astronomy, we can just direct them straight away to quite specific lesson plans, quite specific activities. We could point them in the direction of the Alex's umbrella antenna, for example, which is very simple to build. We could send them towards data that is streaming, live data that's streaming, but they need a structure. They need a sort of do this, do that, step one, step two type materials. Otherwise, teachers are not going to be able to take this up. So, Rich, I don't know whether there's anything at the SARA end that would fit that bill, but if not, then I'll make an effort to start developing some. Is there anything that you're aware of, Rich, that would fit that bill?
No, and there's lots of books, like there's a Radio Jupiter book that I really, and I don't know, we got Richard on board. Yep. The Radio Jupiter book was one of the first things I had that I thought was, very good. And there's a lot of very complicated books that I wouldn't wish on anybody. Like the Klaus book, things like that, which, all of us senior retired engineers have trouble with. When I was doing the radio astronomy formulas on the YouTube, that's what I was trying to do. I was trying to set up, here's some really quick formulas that explain the basics that you can actually, you can actually hand those to the students and say, solve these problems. That's the start I was trying to do for, sort of a lesson plan on teaching people the basics in the math part. Yeah. I don't know. I'd almost say the website, in the analysis section on the website, there's a lot of stuff, but you almost have to walk through it. You need one of us professors to sit there and go through there and make a lesson plan. And there's material to plug into the lesson plan, but it's not in a way that it's like, from start to finish, from no knowledge to, building your own hydrogen antenna. There's just not that sequence.
Yeah. I think that's what was being addressed in the feedback that I got. There are books around, and Richard might have some ideas about the Radio Jupiter, with the state of play with resources there. That's the most obvious one, I think. But that's quite tricky in the getting the timing right. And an antenna for Radio Jupiter, Radio JOVE, is quite a big, physically big antenna. So, I mean, there are certainly some options in there, but I think we need sort of literally a step 1, step 2, step 3, and perhaps as a group we might give that some thought. So Ted's just put up some K-12 lesson plans in the chat. I'll follow those up, and Alex has put some up now as well. So it may be that if I follow some of those, we might be able to find a starting point at least. The thing is that teachers nowadays are so busy. They are just, flat out. They need ready-made resources. Here you are. Here's the PowerPoint. Here's the YouTube video. This is where you buy stuff from. This is when down the local hardware shop or whatever. This is what you need. And otherwise they won't go anywhere near it. That's what I'm finding. I'm finding that with astronomy, but I'm finding it even with physics. Physics is getting shortchanged in schools because teachers see it as too hard, and that's a real problem. It's a massive problem. And as you're saying, Rich, we've got lots of resources within the SARA website, but they're quite high level in many cases. I just wonder around the Zoom room whether other people have ideas. There are some ideas coming up in the chat I can see, but whether there are some other thoughts before we move on to the next thing.
Well, this is Richard. There are materials on the JOVE website.
Yep.
Most of them, I think, were put together about 20 years ago. And,
that's right.
Probably were just moving people from basic physics toward the idea of radio astronomy.
Yes.
The website's been redesigned and repopulated lately, and I honestly haven't looked at the educational part to say any more about it, but that is one place you might look.
Yeah.
And there are some video lessons that are referenced on the website that have been generated lately. So you might take a look at that also.
Yeah, thanks for sharing. I'm aware of quite a lot of that, and that's a very good starting point, I think, to perhaps we have a look at those and see whether they can be distilled down into step 1, step 2, and so on. Also, I wonder whether with Radio JOVE, we talk about the dual dipole, which is quite physically big because of the wavelength. Yeah. Is there an alternative antenna that would work at those frequencies that is more what would I say? Take up less space, let's say.
Well, you can certainly do solar work with a single dipole.
Yes.
And I think that probably helps quite a bit. Another way to do solar work is to move up in frequency. Because solar bursts cover a wide range of the spectrum.
Yes. Well, I certainly, in the paper I talked about 2 meters. Is there a good signal at 2 meters from the sun?
I think there is, yes.
Yeah, because I showed there's I think it's a 3-element Yagi at 2 meters, and they're not. I think it's under $100 Australian, which is very easy to put together. Or I mean, for receiving, you can just about cobble anything together, which is going to give you enough gain to point at the sun. That's the sort of thing I'm thinking of, where you could just go down to the hardware shop, Bunnings in this case, and you buy some PVC pipe, or you buy some copper rod or whatever it is, and away you go. So that might be something that we can do, and have those just a shopping list and a construction list.
I think you're absolutely right, Paul. Particularly with the SDRs, there's a lot more interest, I think, in moving up in frequency. When we had the 20 megahertz single frequency receiver, that's what you were stuck with in terms of the antenna. Although some people have been trying loops at HF, but not with a great deal of success, as I understand it. Yeah. But I think moving up in frequency is probably the easiest answer for a school.
Yes. Yeah, because then the antenna becomes physically smaller.
Right, you can take it out, use it, put it back in the closet when you're done.
Yes. Yeah, that's right. Anyway, I raised that as feedback from my paper. I can run through the PowerPoint if people are interested, but I can't remember whether I did that with this group. But basically covering many of the things that we do as a group, but then trying to find that starting point for each of them. I think solar, meridian sweep or something like that of the sun would be, in tape measure Yagis, thanks Ted. The tape measure one is a really good one. That's very easy to put together. It certainly fits in, that sort of thing fits in with the year 11 and 12 physics course here. Because they do electromagnetic radiation and waves and all that sort of stuff. So that would fit in very well as one of the practical assessments, for example. So let's something I might pursue perhaps at year 10 and year 11. In year 10, they're doing science, which includes physics. As I say, the teachers are very busy and physics gets shortchanged, so it's quite hard to know how to get materials into their hands, but that's the issue.
Hey, Ted, you've got a very successful STEM student. How did the Little Thompson Observatory attract the STEM students, and what are you teaching them?
In the summer, they're hungry for essentially an advanced credit course, I'll call it, where they come over to LTO and we do what they kind of want to. We offer them a bunch of choices. We've built antennas, we built seismometers. There was a cosmic ray detector to some success. One student used that antenna behind me with the red stick in it to look at galactic hydrogen. We'd love to do telescopes with optics too, but of course that means at night, and that's awkward for kids. So they came to us.
Okay. Do you have a curriculum or anything that you, or you just, it's sort of ad hoc right now?
No. What can Ted dream up that matches their interests? Mostly they just want some entertainment. So, okay, sounds good. Many of them don't have building skills, and so we can do that. I can bring in stuff, and we build stuff out of cheap material.
Yeah, and it may be that the STEM area is one that we focus on rather than the mainstream curriculum, because there you do have students who are enthusiastic to go beyond the mainstream course. That might be a target area. We've certainly got the Vic Physics group here in Victoria, and I can put materials out through that. but once I get some materials together. So that might be another approach. But the STEM idea is a good one. That's where you do get the enthusiastic kids who want to go beyond the minimum.
Well, the other resource you could give to these teachers is the grant program we have, where they can order a super SID, an itty bitty telescope, even the scope in the box, and a radio JOVE. And they could, just put in their request. And we're right now everybody's from India, so we'd love to have some U.S. or even Australia come in with some teachers.
Yeah, well, that's a good idea, and that's the sort of thing I can put into the Vic Physics newsletter, which comes out quite often, every couple of weeks, I think, and say, well, in response to the conference paper, here are some immediate resources, and here are some grants and some ready-made equipment you can go and get off the shelf. That's a good idea. Yep. And I'll certainly pursue the radio JOVE just to see what we can distill down there and to get it as a starting point. It may be that we can tap into one of the streaming systems that people have got going for radio JOVE, so that they don't have to build their own, but they can use somebody else's data coming down in real time, and use the planning software to know when things might happen, so they're in the right place at the right time. Lots of options. I shall pursue some of those. Thank you to everyone who's put something in the chat. I'll save those away and pursue them. And then we might move on to Andrew, see what you've got.
Hi, folks. Good to see you. A bit late there doing the Saturday chores, but looking forward to the eclipse coming up. Just on that topic there, Paul, of course, mucking around with loop antennas, and one of my aims is actually to make them, or to characterize them to the point where I can encourage more amateurs to be using loops because they're nice and compact. Having some success certainly with the sun, and also Jupiter, although now my neighborhood seems to have even more interference, and my radio astronomy is a bit crimped now by interference, but anyway, put up with that. I've been doing a few little things trying to understand my antennas, and that's part of working towards a little report on using loops for the Sun and Jupiter. And I'll just try and find this screen here, which hopefully you'll be able to see. So I've been doing some simple stuff with quiet day curves. David Topinski had a nice article in one of the SARA journals in 2017, and just reminded me about a quiet day curve, which is kind of like a mean diurnal variation. And so I've been deriving some mean diurnal variations for a few of my antennas. And speaking of 2 meters, here's my, I've got one of those relatively cheap, I've got a 10 element Yagi at 2 meters with a preamp on it. And I get the galactic background, and solar flares pop through. So yes, definitely something you can do for students there. So that's my 2 meter antenna. And then I've got my loop antenna down here at 39 megahertz. And that also gives me some galactic noise, and maybe even the galactic anti-center. Might even pick up the sun, possibly, certainly the galactic center. Anyway, I've been using Radio Eyes, which is one of Jim Sky's nice products, to understand what I'm seeing, and also to look at sidereal variations. So I'm just collecting data at the moment to make sure I'm actually seeing something that's moving with a sidereal rate, and it's not just some figment of my antenna's imagination. I ended up finding a 45 megahertz map that I popped into Radio Eyes, and that's kind of handy for my 39 megahertz signal here. Here's a plot showing when the antenna should be looking at the galactic anti-center, and that's that dashed line in there. So things seem to line up fairly well. But no, it's interesting. I guess the thing is, sort of checking out your beam pattern. I've got my antenna mounted up on an insulated stick, and even so, I've got a bit of metal in the vicinity, and that's probably altering my beam a little bit, changing my lobes, but that's getting down into the detail. So, bit of fun with that. And what I'm really working towards actually is sort of fully calibrating my system. And the next thing that I'm working towards is the nice calibrator that Richard and others have been working on. And I ended up, I've started to buy the bits. So this is a nice automated calibrator with a little microcomputer that's controlling it, a noise source in here, and some switchable attenuators. I've got my noise source and a few other bits and pieces, and hopefully the next month or so I'll crack on and actually build one of these. So there's a nice manual that describes things, looks pretty straightforward. So that's a bit of fun, and that will give me a way of properly calibrating at least to noise temperature or brightness temperature my systems, which is pretty important when you want to compare your results with others and actually determine if you are sky limited or receiver limited in noise. And hopefully I'm seeing the sky more than I'm seeing my front end system. So that's a bit of fun. And then the other item, I kind of started to use those quiet day curves, which is kind of finding the median signal or the minimum signal, depending on what you're after. I've applied that at VLF and ELF, and I've been looking at some simple things that even I guess kids could do at school, Paul, get into VLF and ELF, depending on how much noise is in your neighborhood. But even at my place, I get a nice diurnal variation at ELF. So this is 500 to 1,000 hertz, really, really low frequencies. And I'm using my super duper simple Earth probe antenna, which is, a couple of electrodes in the ground, an audio transformer to isolate it, and then you go straight into an audio interface. The only expensive part of that's the audio interface. So that's like a USB device that, is essentially a sound card. And that provides the amplification, and I'm getting some nice diurnal variations, and that matches the theory quite well. So this is during the day at my place, a bit high noise. It's really abrupt transition at sunset and sunrise, which relates to the different modal characteristics of the Earth ionosphere waveguide at these frequencies, and I'm just comparing it with some theory that these are at lower frequencies, but still similar patterns. So that's a bit of fun trying to understand all of that, and also the zoo of different ELF and VLF phenomena. I've spent a bit of time looking at things, spherics, those impulsive lightning discharges. You might think they're a bit boring after a while, but I've been looking at them quite closely and seeing things that probably relate to sprites. So what are called Q bursts at ELF, and I'm hunting for ELF whistlers at the moment, which is something that's not seen very much in the literature. Seem to have enough sensitivity because I can see the Schumann resonances at lower frequencies. So getting into a bit of that. So kind of diverted off radio astronomy, well, at least the extraterrestrial, and back into terrestrial at the moment. So that's a bit of an update from me. Thanks.
So Andrew, those look very close to the 20 kilohertz super SID, your daylight and sunset variations. And I guess the questions I've got is, that the supersid versions of the sunrise sunset I'm seeing there are because the ionosphere changes during sunset, but also we're using the VLF transmitters as a source. Now you're at 500 to 1,000 hertz. Are you using some kind of are you getting a signal from something like a transmitter or something that's being reflected, and what is that?
Yeah, so it's just the noise in the Earth ionosphere cavity, and it is the changing height of the ionosphere mainly that's changing that property there. So the attenuation changes between sunset and sunrise. So, yep, just using natural lighting as the source there, or any other noise really. I mean, it could even be domestic noise as well. But yeah, I have a system that looks at the VLF transmitters, measuring sudden enhancement of signal and sudden phase anomalies. And yes, I've applied that to that as well, and looking at quiet day curves. Quiet day curves are quite useful. Helps you remove that diurnal variation and helps you see the small effects a little bit more clearly. So actually, I'm working on a paper from the eclipse when was it? Last year up at Exmouth, Western Australia. And I've applied that in that paper there. So yeah, no, it's quite interesting at VLF, looking at the solar flare effects and using the transmitters or the natural sources to look at variations.
Andrew, that ELF, is that extra low frequency? Is that?
Yeah, below 3 kilohertz. So the propagation mode is different there. It's more of a magnetic mode. And my Earth probe antenna actually is quite sensitive to that ELF band as well. So yes, I spent many years mucking around with whip antennas and loop antennas, and the Earth probe is so simple, and I've done such a lot with it. Yeah, whistlers and all sorts of other things, gamma ray bursts, and as I say, the advantage is that it's relatively insensitive to noise, local noise, and you don't need to muck around too much with electronics for it.
How deep does the probe go?
Sorry?
How deep does the probe go down?
No, I've only got 30 centimeters for me. It's just, in fact, I just started off. I had some copper rods I bought for I built a Yagi, and I had some. I tried aluminium and copper, and copper's easier to solder, so I used the copper, and yeah, I repurposed those. I thought, oh, I'll just try it out, just bash it in the ground, see what happens. I thought, gee, am I going to need like a meter or two, or am I going to have to muck around with chemical, probes, because there are ways of really coupling to the soil if you use copper solutions and all sorts of other things. But no, just bash her in with a hammer, solder some wire to it, and you're away.
Wow.
You mentioned a transformer or some kind of connection. So you got two probes, you put wires between them, but in the middle you put a transformer. Describe that transformer. Is it many turns, or is it just 1-to-1? What do we got?
It's what I had in my kit was just I think it's a 1 kilo ohm to 8 ohm audio transformer. Actually, it was one that was left over way back. Casper Hosfield from the AA BSO sent me some bits and pieces when I was just a lad, and I've reused one of Casper's Radio Shack audio transformers, and well, that's what I had. And I thought, oh yeah, okay, I'll try that. It might be better with a 1-to-1, but I haven't even tried that yet. But yeah, and then the other side of the transformer. So what have I got? I think it's the 8 ohm. So no, it might be the 1 kilo ohm side goes to the stereo input of one of the channels. of
And
my,
so if it's not 1-to-1, I guess I want more turnings on the above the ground end,
yes,
so that
that's right. You're
we're
right.
kind of upping the
Yep,
voltage a little bit.
you're right. Yep, it is. It is. Yep, exactly right. Yep.
Great experimentation now that the ground is not frozen. Okay.
Yeah. Try that. My ground is super duper duper dry at the moment. It's the driest uh period we've had on record now in our place, which is quite a contrast to the rest of Australia. Still working fine. It tends to vary a little bit when it gets wet, but I've got sort of a soil that well, it's not even soil really, it's clay. Seems to conduct fairly well. So
That was going to be my question, Andrew. Do you have to go and water it every now and then to, to get the conductivity?
yeah, well, that's
Well,
another experiment. Yeah, look, I've got a soil moisture probe which I was measuring the soil moisture for a while until the sheep trod on it. Then yeah, I have to get that back in and collect some data and see. Now I've got my quiet day curves going, I can probably quantify things a bit better. And yeah, I've also calibrating my system with an accurate measurement of its full scale voltage swing. So that'll be useful too.
well, I'm on pure sand here. There's no clay
Yeah.
content at all, really. And we've
Worth
had
trying.
no rain for weeks. It's
Right.
just
So
the I try to grow vegetables, and that just then it's not happening. And it's very different from the way it used to be. I used to go and buy punnets of vegetables, stick them in the ground, water them in, and then that was it, and they would grow, and away you go. Now, no, it's just too dry, and being so sandy, it just becomes dust. It just blows away.
yeah. So
So
yeah.
I've moved to hydroponics. Hydroponics is a way around that.
Yes. Like even my wife's cactuses are dying now. So dry.
Yep, it's crazy. It really is. For some time, I've not put any vegetables in over our summer because it's too searingly hot. But the non-growing season is getting longer, so hydroponics is the answer. And just in reference to Andrew's VLF stuff there, just turn the blur off. I got this little box, which is not really exciting to look at, but it's quite exciting inside. Antenna input for the LF, and then this comes out on 10 megs. So it's a converter, and it's made locally. It's made in it's PK loop antennas. Andrew, you may have come across them.
Oh yeah.
It's a guy in Melbourne making these, and he makes the loops as well. His original business was for people traveling in caravan, the grey nomads and all that sort of stuff, heading around Australia, who wanted to continue to receive particularly AM radio. So he's got boosters loop. He's have a loop that you put close to your AM radio, and then preamps and stuff. And so as they travel around Australia, which our friends in America would be aware, it's a very big place with lots of nothing in it, that they can extend their AM radio reception. This particular one, then he's made for LF in or VLF in and 10 megs out. So I just connect it to my amateur transceiver. And then so you just add 10 megs and there you've got a band sitting above 10 megs that you can go through. It's very good for those what do we call them? For the aircraft, the NDBs. There are still some NDBs left in Australia, and given the distances, it's quite interesting to trawl around and see where you can get the NDB signals from, and look at the variation in their transmission. So I get NDB signals from Queensland, certainly from Tasmania, South Australia, and even across to Western Australia sometimes if the conditions are right. So that's, as I say, that's locally made, and he does make loops. So there might be something there that we can do to get
Yeah.
him to prototype a loop for us.
Yeah, I had a look at that. That's quite interesting. Yeah, those NDBs, yes, I've monitored some of those for ionospheric disturbances too. That's quite interesting. Quite simple to do.
Yeah, I mean, we're losing them at a rapid rate. The NDBs are being turned off. There used to be, I don't know how many hundreds of them. Now you look through the list and you see turned off, turned off, turned off, because they've got other ways of navigating. But there's still quite a number around for the light aircraft that are still using them. All right, so I think Andrew, any more? Is that it?
No, that's me. Thanks.
Yeah, sounds like you've got plenty on there, as always. Now, Rob, I know you're in America, but we'll count you in the Australian group. So give us oh no, and I know what I was going to do. Sorry, before we go to Rob, I was just going to jump to my PowerPoint. So I should be able to share the screen. Where is it? This one. Now, is that sharing correctly? Yep. That you're getting yourselves in the middle of it.
Yes, and we see the pictures down the left-hand side too.
Yeah, so I can, if I go to from the current slide, that should make it full. It should be full screen now.
Now it's big. Good.
Yeah. So one of the points I was making, this is from my presentation at the conference, was the what waves, what radio waves, or what generally what light waves can come in through the Earth's atmosphere. I thought this was quite a good diagram to illustrate it. Gives you the range of wavelengths and the approximate size. But then here's the visibility for visible light, a little bit of ultraviolet, and a bit of short wavelength infrared coming in from space, from the sun specifically. And that's clearly why we've evolved the way we have. So, we've evolved to detect the light that's available. But then nothing else apart from this little window up here, which is where we are in the radio astronomy and just a little bit into the microwave. So that fits in very nicely with the physics curriculum, particularly at senior level. But then I said, all right, well, if you want to receive light in its general sense, not just visible light, but light, you have to go and put your detectors into space. So you can have orbiting telescopes, or you can send the James Webb out way to the Lagrange 2 point and get fantastic pictures like this, which are just amazing. And the one on the left is always good because apart from the ones with the diffraction spikes, which are basically close by stars, just about everything in that photograph is a galaxy. And it gives teachers and students an idea of just what we're dealing with in space. And also you've got gravitational lensing in that particular shot. So it's a really, really good one. You could do a whole lecture on that image alone. Just what are we looking at? These spiral galaxies and cigar galaxies and so on, plus the gravitational lensing. There's so much in that. Then I went on to space weather, which I think is quite a good one for immediate access, and that's what, to some degree, Andrew, it's what you were touching on with changes in the ionosphere and so on. The Bureau of Meteorology, the BOM, has live information coming in on space weather and the conditions of the atmosphere and the ionosphere. And that led me through to C-Star. So that's why I'm putting this in now, because I think Rob has his C-Star with him. This is something that a school could do just to monitor the state of the sun. So because you can go and grab an image of the sun at zero notice, or you can go and get one from the NASA SOHO website, and then you can match it up with the space weather information that's coming from the Bureau or from spaceweather.com. So that's all accessible and at zero cost, really, because you can get the images for zero cost. You can get the space weather information at zero cost. And so going back to my earlier thing, I think it's just a question of getting some materials together so that we can guide a teacher through what they need to do at each stage and therefore what they can do with their students. That's the SOHO stuff, which that's not a live image, but you can get the live image from SOHO. And there's an animation, which is quite nice. I think I've mentioned before, I had a student who used that animation, collected a week's worth of data, and then she did some measurements and actually calculated the period of orbit of the period of rotation of the sun. And she got within 7% of the book value, which was pretty good. And there's the little simple antenna that could be used at 2 meters. It's actually 5 elements. I don't think you'd even need 5. But it's the sort of thing you could put together. A tape measure antenna or some rods would easily give you some drift scan sort of thing like this. So those are the ideas. Oh, there's the loop and there's the SID, super SID. That's something that, and picking up your point, Rich, there are grants for this. So we could easily arrange schools to get some of these. And if we got enough schools, we could be comparing data and, getting a bit of a group together using them. And there's the radio JOVE stuff that I went through as well. So lots to get into, but I thought it was relevant because I know that Rob was planning to take his SARA telescope with him. Rob, over to you, and give us an update on what you're up to.
Well, I've actually brought my SARA. It's here. I can pick it up and show it to you. It's right here. Yep, here it is.
Mm-hmm.
Mark it back there.
Mine's on the floor behind me.
So what I was trying to do was the sun's corona during the total eclipse is about the brightness of a full moon. So I went out and I took some pictures of the moon, as with the SARA, as well as some pictures of the sun. And what I've been trying to do is to get the H alpha telescope, up and running. Yeah, but the sun, the clouds are fighting me right now. So I have to wait for some clear skies. But I have seen some images of the sun through the telescope, and they're crystal clear. And the day star, prominence quark that I have, you can adjust it to do prominences, or you can do the corona, chromosphere, type of thing. So outside, so basically I've just been playing with that and getting getting my presentation ready to go. Now, I know people keep seeing all these beautiful pictures of the sun's corona during totality. And, what I did was I received a report from someone who did those beautiful pictures from the total eclipse in Exmouth. And the comment that he made was, he took 300 hours to make that picture. It took 300 hours on his computer to make those pictures. So basically what I'm trying to do is to figure out what's the best way to, to present, the total eclipse with the SARA. I know people look at it and they go, oh, the field of view isn't big enough to see all of the corona, but the chances of seeing much of the corona during totality, it isn't going to be that good. But but some people will get pictures of it, out 3 or 4 discs, from the surface, and but it'll take some time to get those processed, type of thing. Yeah, lots of time, lots of Photoshop.
Don't forget to put your solar filter back on after totality.
I updated my total my eclipse. I think I've been to like 37 or 38 eclipses. So I have no idea. I've actually I've got a picture of the map of all the countries I've been to. I think I've been to 17 countries or something like that.
That's amazing.
Yes.
Yes. You know what you're doing, Rob. There's no doubt. Now, are you able to stream it? Have you looked in that?
From what I understand, we can use the C-Star, and the University of Texas has their internet. Should be able to use that to stream. And I think Bob Strickland is trying to help out with that.
Right.
So we keep our fingers crossed.
Yeah.
And hopefully be able to show everybody what the total eclipse is.
All right. So we'd need a URL. Then what would it go through?
I'm waiting to find out about that.
Yeah. Okay.
Yeah.
Well, we'll watch that space then, and perhaps Rich, an email can go around or on the listserv when we know more about what's happening.
Yes. Going to happen soon because it's only a couple of weeks away.
Yeah. Very close now.
Yes. So that's basically it for me.
Right. Well, sounds like you've got plenty on your hands. Andrew is very busy. I've got lots to do, and that's it from the Australian end. Rich, so over to you.
All right. Oh, let's see. Ted, what do you got going on?
I wish I had more to report. No, I'm just kind of poking away slowly on Ezra. There are a couple more enhancements I want to do, and I keep finding bugs here and there little tweaks I need to improve. It's still alive. No antenna activity recently. So many things to do. Back to you.
Now, Ted, what would you say for high school students with Paul's thing? I would say that Ezra was the right package to use for high schoolers, at least, because it shows you all the different pictures, and that's what they like. Is that you think a high school student could pick that up?
That's been proven already in a couple of different continents, so that's good. Ezra is simply a tool to save you from doing all that software stuff and organizing it and figuring out the equations and getting the dang programming to work right and plotting and stuff. I've just tried to provide what I got, and if it helps others, that's just great. It's not the be all and end all, but at least it helps a bunch, and that seems to have been proven. That's all. But high schoolers, exactly. That's been working well. There are always the awkwardnesses of you got to apply power to the LNA. That might require some software to tell the SDR to send the power on. The cable has to be right. You worry about connectors. So all those physical things you're learning, I can't do that for you. You got to learn it yourself, often by mistakes. And that's fine. Learning process.
All right. Okay, thanks. Helen.
I'm here. Can you hear me?
We can.
Oh, okay. No, still watching and learning. And our friends are really impressed with the scope. I says you'll be even more impressed when we finish getting it up and running and see all that it can do. And I guess that's it for right now. I'm still working through the health issues, so they got me on home health, so they're not letting me out. So I'm just reading and doing what I can in here for the time being. But I am learning and I am enjoying it, and I'm grateful you're letting me be part of your group.
Now, Helen, you talk about telescope. What kind? Is this radio or optical?
No, I bought a scope in the box.
Oh, we've got you hooked that far. Wonderful.
Yeah, we've got it. We got to do the part now with the computer, which I need to haul over to Best Buy so they can work on it. But we live in remote or somewhat remote Arizona. So, I mean, we're a good hour and a quarter from Best Buy that can actually help me fix it. So, I need a ride and to set up like that. And for the time being, they're not letting me out here for another month or so. So we'll get it going.
Should you and I talk by email and try to do it without you needing to travel?
Yes, that could work.
We'll see if we can get that arranged. I will email you.
Okay, thank you
Or
so
you can
much.
find my address on my website for Ezra and come get me too. I'll
Okay, thank you. I appreciate it.
All right. Alex.
Good evening. I don't really have anything. I do want to share one slide on the topic of education for younger kids, and it's this, maybe. The aspect of hydrogen line being the SETI frequency. And I think that would really intrigue a lot of younger people, thinking that maybe within that hiss might there be some alien transmissions. I think that certainly would be worth including in your talks. And I sent this Matthew George, a professor in India, built one of the disc Yagis, and that's what I was saying, referencing here. I just snipped this out of an email that I sent him, and the space gun would make an interesting demo. So this could all fit together, but I think telling them that the 14, 20, 21 centimeter frequency was designated or considered potentially the SETI frequency because it is so widely distributed throughout the universe that that might be the frequency that extraterrestrials might use to try to communicate. I think that would be worth adding to your presentation.
That sounds like
Yep.
fun, Alex. I'm just worried about aiming space guns at aliens. Don't get us in trouble.
No, that's the antenna, the disc Yagi.
I know exactly.
Okay. I just lost Alex.
No, I'm here.
Okay.
I got yeah, that's right. I'm up and running. We shouldn't have any more shutdowns. I got WOW fiber internet installed 2 days ago, 100
Nice.
megabit, and haven't had a dropout since.
All right. Okay. Don Latham.
Howdy. I've got nothing really new. If you're doing earth electrodes, what we used to use in the old days was a little chunk of lead sheet, buried about 2 feet in the ground, and bedded in clay, either bentonite or whatever's around, and you moisten the clay and then lead up with a piece of coax so that your electrode is buried well below the surface. Those last quite well. And then we used to run them straight into a Varian recorder for DC to whatever. If you use lead and bentonite, soak it with a little copper salt on it, copper sulfate solution, and make sure it's buried well. And it should stay moist for a long time. And that'll give you the best connection to the earth. And then the Varian, of course, was a high input impedance machine that DC balanced to prevents the electrode from becoming polarized, which it'll do if you try to draw too much current from it. So if you're just doing an AC measurement, probably won't have that problem with a more modern kind of machinery. That was, after all, 1962. I think we got better stuff these days. So that if you really want to do air earth currents, then we had some excellent surplus coax, so we ran 1,000-foot baseline. I don't think you have to do that. You can use a lot shorter baseline, as has been pointed out. Outside of that, nothing new.
All right. Okay, thanks, Don.
Yep.
Richard Flagg.
Really nothing new, Rich.
Oh, okay. And we did get a Japanese member on a Drake's Lounge on Sunday. So I think he's also in the close to the Australian time zone. And bring that up because Richard's in Hawaii. So he's like, I don't know, what time is it there?
At 1 o'clock. 1 o'clock in the
Yeah, so
afternoon.
that's a decent time, I guess. Yeah.
Yeah, it's a great time.
Perfect.
Okay. Let's see, Kim and Kevin, and I think that's Baby Yoda.
You got it right, yes. Not too much happening up here in Canada. We're just in the start of a 15-centimeter snowstorm for those in Australia that would love to see the precipitation, but otherwise we're waiting for things to melt before we can get back out there and see how things are surviving in the radio JOVE antenna and things like that.
Okay. All right, thanks. Let's see, Preston.
Okay, I haven't done a whole lot. I've been getting over another episode of COVID, but I'm fine now. So anyway, I took a few minutes in anticipation of the eclipse and tested my filter on a telephoto. I've got a ND 100,000 filter, and I put that on my telephoto and took some handheld shots of the sun just for practice at 500 millimeters, and I could see sunspots, and I was very pleased. So I'm ready to use my camera in Texas, and that's about it. Oh, go ahead.
Does it have an IR filter, Preston? Is it IR? Does it remove the IR?
No.
No, you might want to add that. I mean, if it works, I guess it works, but that's always potentially an issue. If you get heat, you might damage the camera.
Yeah, that's a good point. I might try just holding the filter up over my skin one day and see if I can feel the skin heat up any. I don't know. I don't know how to test it. Any ideas?
I just add one. Just buy one. Buy an
Okay.
IR filter. Try that.
Okay.
A glass bulb thermometer.
Yeah. Okay. Well, I'll see if I can get a filter. Thank you.
What kind of a camera is it?
An IR block.
Yeah, IR block. Yeah, it's a Canon. What? R6, I guess.
Oh, it's a mirrorless.
Yeah,
Yeah.
mirrorless. And it's a nice little camera.
You can just buy an IR filter to just put on the front of the lens.
Okay, I'll do that. Thank you.
Welcome.
Glad I asked or told or whatever.
And
Okay.
SARA does not condone self-testing of, so no more self-testing, Preston. Using your skin is not what we condone.
Okay.
All right. Wendy.
Hey, y'all. So I have nothing much going on. We're doing home health things. Preston, did you can I ask, is this you had COVID? Is this your first time?
No, second time, and then this time is kind of mild. I had it 15 months ago, and it was a lot worse. But no, it hasn't been too bad.
Well, it's just odd. I've been talking to someone this very day who was saying, "Oh, it's not so bad." And it's like every time I hear somebody say that, the next thing I hear is someone who's like having issues with it. So, but anyway, I hope you feel better.
Oh yeah, I already feel better. I'm using the medicine they say, which is controversial, Paxlovid, and also, I guess over the last few years, I've had 6 shots, so that should have helped something.
6, you mean like mitigation stuff or vaccine stuff?
Vaccine, yeah.
Yeah, the virus mutates so rapidly.
Yeah.
You
So,
try to keep up with it. I just try to keep away from people, but there seems to be as many theories as we, there's so many theories. Well,
yeah.
anyway, we're not doing much except I took all of my. I'm trying to install various pieces of diagnostic equipment into my wonderful equipment shelf. And I think I'm going to get some Faraday cloth just because I want to play with it and try to do some experimenting on seeing how that changes things. Other than that, not much. And of course, I'm sorry, Preston, but I just have to do it. Did you see a doctor or just spots?
Yes, I went to my local doctor. Yes.
No, I mean, there's an old joke. You said you were looking
Oh.
through your telescope and you saw spots. I'm sorry, but I just can't help it. Anyway, that's it for me.
That's good. Thank you.
I don't know how to. Bruce, can you? Your turn.
Oh, sure. Hello, everyone. I haven't listened in for quite a while, and it's been a kind of a pleasure to listen in while I'm doing things out here in the backyard. I call myself a student of Ted Klein. He's helped me out quite a bit with the 21 centimeter stuff, and I'll show you. I had a little snowstorm. Well, Ted knows we had a big snowstorm, and it kind of tore up I have this, there it is, this little homemade dish that I made. It's about 1.7 meter, and doing the Ezra stuff and enjoying that, collecting a lot of data and learning about the galactic hydrogen. And I enjoy listening to you guys because you're also knowledgeable. Sorry, I'm out of breath. I've been moving around back here. I did enjoy the Sea Star part. I am going to be at a local library with our club. I won't be able to get to totality, so we're going to do a partial up here, and I'm going to use my Sea Star, set it up with I'm going to have a telescope and probably, I don't know, I might do a pinhole. I'll see what I set up on the table, but there'll be several of us there at the library. But thanks for the invite, for letting me listen in.
All right, you're welcome. Glad to have you. Okay, Paul, that's all our group. You got anything else?
I've got a few photos, Rich, which are on my iPad. I'm going to try and share my iPad. If it works, I'll explain what's going on. Share screen, iPad, and then it's a funny one. Sometimes it works first go, and sometimes it doesn't. I'll see what happens. No, it's not going to do it. It's weird. I don't understand why it works sometimes and not others. Not the shade. The alternative is to hold it to the camera. It may work. Lost it. Not gonna work. All I'm doing is getting reflections. I'll have them ready for next time. I was out at a friend's dark sky site, and we got some magnificent photographs of the Milky Way and Southern Cross and so on. And then we were all just standing there, and a Starlink train came through, which was and there was a very soon after launch. I don't know whether you've ever seen the Starlink, but it was a very, very short train, very, very close together. We could count 21 satellites in that. It's an amazing system. It's a really good system, but it's bloody awful for astronomy. It's going to make astronomy much, much harder once they get all these satellites up. So it's a sort of two-edged sword, Starlink. But no, I'll have some pictures ready for next time, Rich, and my hardware is not going to play nicely today.
Well, great. Well, thanks, Paul. Any last words from anybody? And if not, we'll go ahead and sign off.
Okay, very good. April the 27th, I think it is next time.
Right.
All right.